Today, the Faculty of Environment Ecology Lab staff will demonstrate how to examine the characteristics of snow. We will be using a snow sampling kit that can be obtained from the Ecology Lab for your needs. Understanding the characteristics of snow can give an indication of snow stability that helps in predicting avalanche-prone conditions. As well, the data can help us in estimating snow water equivalent and the potential for meltwater runoff that may cause flooding. To demonstrate snow sampling, we will dig a snow pit. It is ideal to choose a representative area, not an area with piled up snow, disturbed, or obvious obstructions like rocks and trees. The first thing we want to do outside at our sampling location is to allow the equipment within the kit to acclimatize. This is done to prevent snow from melting while sampling and to have accurate readings. While the equipment is acclimatizing, observations about your site should be recorded in either your field notebook or on a data sheet. Be sure to include the observers, the location, date and time, elevation of the area, aspect, this is which direction the slope is facing and the compass will help, current weather. If you have a Kestrel weather meter, you can use that instrument or look up the local weather online. Be sure to include your air temperature, wind direction and speed, your cloud cover, as well observe the type of precipitation. The traditional and most accurate way to sample snow is to dig a relatively deep snow pit. Here in southern Ontario, in our winters, 50 centimeters is deep, but this is relative depending on your location. Dig a small snow pit with a shovel and be sure to take out the snow within your pit. Using a scraper, make smooth edges along the inner snow wall. Now look at the layers in your snowpack. You should be able to see melt lines, where new snow has fallen, etc. There is a brush in your kit that can be used to remove loose grains on the inner sidewall of the snow pit and make the layers more visible. Measure the depth of each layer and the total depth of the pit using the ruler. As well, you can use a twig to delineate your snow layers. Snow has low thermal conductivity. It is a slow conductor of heat. Because of this, there is generally a temperature gradient in the snowpack, with the top affected mainly by the cold air above, while the bottom is warmed by the ground. It is this property which makes snow a good insulator. As well, dense, frozen conditions have low insulative properties versus light, fluffy snow. Think of a feather duvet blanket. To determine temperature, take your thermometer and place it in the snow horizontally. It may take a few minutes to stabilize. Take the temperature at the ground or at 0 centimeters, then at 5 centimeter intervals. Also record the air temperature just above the snow surface. There are several snow tests that we can conduct. The first one is determining grain size. We will do this for each layer. Place a small sample of snow on the grain size chart, which is a millimeter grid. Each square is 1 millimeter. Compare the grains against our grain size chart to determine the size. Be sure to record your observations. Using our scraper, we can work into the next layer and place the snow on our grid card to determine the size. And be sure to record your observations. With your snow sample on the grain size chart, we can examine the snow grain shape using a hand lens. I have a 10 times hand magnifier here. Categorize the snow according to the chart that is displayed and do this for each snow layer. There is a snow hardness test, also called the hand hardness. In each snow layer, gently and slowly press a specified object into the snow. You can start with your fist, and if it easily penetrates the snow is very soft. For our example, our snow pit is not that deep, so I will use 4 fingers instead. If those fingers do not penetrate through, you can reduce down to 3 fingers, 2 fingers, 1, and then moving on to objects such as a pencil. Use the table displayed to record the hardness of each snow layer. The next test is to determine snow density. The thermal conductivity of snow is closely related to the density of snow, which will change over time. Fresh snow may have a density of 0.10 grams per centimeters cubed, while old snow, the density could be 0.40 grams centimeters cubed. Since density will change with the layers of snow, perform this calculation for each layer and add them together. To determine density, you will need the snow sampler, the scraper, the cloth bag, and scale. The first step is to weigh the cloth bag on the spring scale and record the weight of that bag. Taking the snow sampler, push the sampler horizontally into the inner wall of the snow pit in an area that has not been touched by any other tool. Use the attachment to scrape off any excess snow. Notice our snow sampler is custom made and it is 250 cc or centimeters cubed in size. Place the snow collected into the cloth bag, hang it on the spring scale to weigh both the bag with the snow. Be sure to subtract the original weight of the bag from the total weight. Calculate density by taking the measured weight in grams and divide it by the size of the snow sampler, which in our case is 250 centimeters cubed. We can determine water content or wetness of our snow sample. Take a sample of your snow and start handling it. Squish it in your hand, try to roll it into a ball. See if the snow grains stick together, if it will make a good snowball, if there is water visible, could that water be squeezed out? Using the table displayed, determine the free water content in your snow sample.